So you guys still never erased any of those numbers. Okay, don't forget the quiz is tomorrow. Make sure you have your graphic calculator, and in the morning I will have practice quiz on the board here. Oh, this is extra work for me. No, you know what? I'll do anything to help you guys get a 5 on the AP. What is this all? Who wrote that? If you really need help on all, then you should be coming in for help. All right, what section are we on? 3.3, huh?
Yeah.
So we're just learning the shortcuts for computing derivatives. This should be easy. I bet you, if you came in for help, like on just the first few problems, I bet they'll solve almost all the other ones. I bet. Number 7, find the equation of the horizontal tangents. Now, what the heck is a horizontal tangent? Okay, like this is a cubic function. If you graph this, it looks something like this. What? So, where on this graph will the tangent line be horizontal? Probably like bing, and then bing, like that, right? What's the slope of a horizontal line? 0. So we want to find where on this graph is the slope 0. Well, what tells you the slope of a graph? The derivative, that's right. So the derivative of this is 3x squared minus
4 minus 4x plus 1.
What is this?
Oh, it sounds like.
Yeah, I can see that. Why, the thing ran long or something?
Yeah.
Minus 4x plus 1. Did I compute the derivative correctly?
Yes.
Of course, I'm the teacher. So now, see, in the beginning problems, that's all you had to do was compute the derivative. But now we got to compute what are these horizontal tangents. So where is the slope equal to 0? Can I solve this equation? Yeah. You factor it. I believe this is factorable. 3x and x, 1 and 1, minus minus. So when x equals 1/3 or 1, that's when you have the tangent line being horizontal. So the x coordinate here would be 1/3, and over there would be 1. And what are they even asking for? It says find the actual horizontal tangents. So that means we need to compute the y coordinates. Well, if you know the x coordinates, how do you find the y coordinates? Plug it back in. Okay, I'm not going to do everything for you. I will do this one. You guys plug in the fraction. If I plug in 1, you get 1 minus 2 plus 1 plus 1. What is that? 1. So what's the equation of this horizontal line right here? Y equals, what's the y coordinate?
Didn't you?
1.
I think you only need to find the x
Yeah,
squared.
you don't need that.
Are you sure?
That's what the answers in the back show.
No. The direction says to find the horizontal tangents. That means they want the equation of that horizontal line.
But the answers say at the
I don't care what the answer is. I'm telling you what yeah! Otherwise, the directions would be find the values of x at which there is a horizontal tangent. But that's not what I see there. Okay, never mind. At least you put it in numerical order. Thank you. 21. No!
18.
Oh, boo-hoo, 18. Y equals x squared plus 5x minus 1. Come on, is this problem up here just because it's even? Okay, well, I see a quotient. So you either use the quotient rule, or what's another thing you could do since there's just a single term in the denominator? You can lift and separate which one you want to do. It doesn't matter, it's going to come out the same. It's just like eating oatmeal with blueberries or oatmeal with strawberries. At the end, it's going to come out the same, right? So what do you guys want to do? Quotient rule or lift and separate? Okay. What is x squared over x squared? 1. What's 5x over x squared? 5 over x, but you probably want to write it like that, yeah? X to the negative 1. And then minus 1 over x squared, which is x to the negative 2, correct? Now it's ready for differentiation. So the derivative of 1 is Okay, you guys gotta tell me. Hazal Malam, derivative.
-5 over x squared.
Ooh, trying to impress me, huh? Okay, good. Continue.
Oh, okay. My plus 2 over x.
Yeah, you impressed
Oh,
me,
cubed.
and then you depressed me. So here's time and me, Mr. Park. I got impressed a little bit, and then you depressed me. Okay, what's the derivative of this? -2x to the -3. You gotta reduce the power by 1. So what should it be? X cubed. And then, of course, if you make a least common denominator x cubed, it'll be -5x plus 2 on the top there. Bam! You guys gotta get used to making least common denominator, because again, next chapter, you know what we're gonna do? We're gonna take the derivative, and then you gotta make a number line. But in order for you to make a number line, it's gotta be in factor form, you gotta have least common denominator. See, so sometimes you have different ways of doing the problem, like if you use the quotient rule, didn't you guys come out to the same answer? Who used quotient rule? Did it come out to the same answer? If it didn't, then we did bad algebra. That's what happened. Okay, number 21. That's okay, we got lots of problems, it's on video. That'll help people. Y equal x squared over 1 minus x cubed. Can I lift and separate in this one? No, you cannot, because there's 2 terms in the denominator. So you have no choice, you gotta use the quotient rule. Have you memorized it? Don't you hear your friends in BC going low d high minus high d low over denominator squared we go? I don't have friends in BC. Okay. Derivative low. Okay, I can do this. You guys gotta do this. Tanaka, finish it off.
Yeah, okay. Times 2x minus x squared times -3x squared all over 1 minus x cubed squared.
That's exactly right. Low d high minus high d low all over denominator squared we go. Okay, I'm not gonna do any more. You guys should know how to do algebra 1 to simplify that, yeah? If cannot, see me for help. Or go back. You know what? Did you guys keep your receipt from algebra 1 and 2? Because then you can go back and get your money. Get your receipt. It's not working. 23. So, no, okay. 23 got A, B, C, D. I am not going to do all of them. I'll do one of them, and I think you can do the rest then. Okay, I will do. Okay, 20. These are the. Okay, I'll do B. Compute the derivative of u over v when x equals 0. Well, remember, this symbol here means compute the derivative of whatever's next to it, yeah? Well, I see a quotient there. What should I do? Make up my own or use the quotient rule? Okay, very good. You guys are picking the right one. So how does the quotient rule work? Low d high minus high d low all over denominator squared we go. Right? You guys know prime means derivative, right? And then they want you to plug in 0. So what happens when you plug in 0 into the v function? Well, that's why they gave you all of these numbers. What is v of 0? Somebody help me out here because I don't have my glasses. Negative, so this is -1. What is u prime of 0? Okay, I'm trusting you guys. What is u of 0?
5.
And v prime 0.
2.
And then v of 0.
1.
Well, -1 squared. And then just compute that number. So apply the rule and plug in 0. That's all they want you to do. So for example, here, I'll do another one. D. That's the easiest one. Okay, let's do D.
Oh yeah.
Okay. Did you guys use the product rule on A then?
Yeah.
I know what some of you are saying. Wait, let me look at the problem for the first time now. You guys don't think, come on, I've been teaching 33 years. I know what goes on. How do you compute the derivative? Okay, this is 7. How do you compute the derivative when you have a constant? You throw the constant on the side like an unwanted pet, and then you multiply it by the derivative of this. What's the derivative of v? V prime, right? Same thing over here. Throw the 2 on the side like an unwanted pet, and then multiply it by the derivative of u, which is u prime. Now just plug in 0. You guys can plug in 0? Okay, I'll do it. Okay, what is v prime of 0? I can just look over here, it's 2. What is u prime of 0? That would be this one, -3. I will leave the computation to you, but I can see that's 20. 14 plus 6, 20, there. So that problem, okay, I'm telling you, Randy, it's not gonna be on, oh, it is. This is on tomorrow's quiz. That's okay, you can see it on the board if you come in tomorrow morning. What's so hard about it? Either use the product rule, the quotient rule, or the whatever this rule is, and then plug in the number. It's on the chart. It's easy. It's like guaranteed points, unless you miss it. 25. This just goes on and on, doesn't it? 25. Which of the following numbers is this? This is a multiple choice! And it's odd. It says, what computes the slope of the tangent line? Okay, this problem, I'll tell you right now, it's too easy to do on the quiz. Okay, when x equals 3, they want to know what is the slope of the tangent line. Well, what tells you the slope of the tangent line? The derivative. So you compute the derivative. This one's just too easy. 2x plus 5. Then you plug in 3. 6 plus 5, 11. Bam. That's it. The derivative is a formula that tells you the slope of the tangent line, right? Okay, 27. Are we doing? Yup, 27 is there. Find an equation for the tangent line. Okay, so here we go. Okay, what are the two things you need to write an equation of a tangent line? You need a point. Okay, now they give you the x coordinate is 1. Let me double check that. Yeah. How do you find the y coordinate? Plug it in. I'll tell you right now, this problem's on tomorrow's quiz. Okay. So if I plug in 1, you get 1 plus 1 over 2. That's 1. Now, how do you compute the slope of the tangent line? You gotta compute the derivative. The derivative tells you the slope. So, what do you want to do? You got two choices here: quotient rule or lift and separate. Are you gonna see that tomorrow though? Probably not. So, what do you want? Just quotient rule? You tell me, because I don't care. It's like again, it's strawberry oatmeal or blueberry oatmeal. It's gonna come out the same in the end. So, what do you like better, strawberry or blueberry? I kind of like the brown sugar cinnamon. Well, you don't have that choice right now. So tell me, come on. Okay, let's do quotient rule then. Low. Okay, I can do this. You guys got to do it. Go. Read it off your paper. What?
Oh.
Go.
Wait, what? Oh, sorry.
Oh, the voice changed. What? Go.
Oh,
Go.
okay. Okay, 2x times 3x squared minus two times.
Gotta be different. There's always one person. Always gotta be different. Look, low d high minus high d low all over what?
4x squared.
Ooh, trying to impress me, huh? Okay, good. Now, this is not the slope now. It is not the slope until you actually plug in the number. So you have to plug in the x coordinate here to get the slope now. That is not the slope. It's a formula for the slope. So if I plug in 1 for x, what do you get? 2 times 3 minus 2 times 2 all over 4. What is that? 6 minus 4 is 2/4, which is 1/2. Did you guys get 1/2? And then just point slope pagkatize it. Y minus 1 equal 1/2 times x minus 1. Bam! There's your answer. Yeah! So, can you repeat this problem tomorrow? This problem on tomorrow's quiz. Probability 1. Next, number 27. 27, 31. This
Oh,
is,
this one was
we're
so
not even
hard.
making headway. It's just like, what? Is this all? This kind of feels like all the problems.
It's like every other.
Oh, every other. Wow. How stupid of me. Okay, I see a quotient. I think I'm going to use the quotient rule. Read it off your paper. Apply.
root x plus 1 times 1/2 x to the negative half minus root x minus 1 times 1/2 x to the negative half all over root x plus 1 quantity squared.
That is correct. Now tomorrow you're gonna have a problem like this on the quiz too. Now if you write that down, you actually did the quotient rule, I'll give you 2 out of 4 points. You want the other 2 points, you gotta simplify it. Did everybody get this? Did we at least secure the 2 points? Okay, how do you simplify this grid, Mr. Park? Well, look at the numerator. What can be factored out from the numerator? I see gorilla here and gorilla there. Can't they factor out gorilla then? Okay, factor out the gorilla. What's left? Root x plus 1, and then this minus sign you gotta distribute down. Like that. Is that the problem? You guys not distributizing? And then, hey! Root x cancel out. What's 1 plus 1? What's 1 plus 1? 2. Doesn't the 2 cancel that too? So your final answer will be 1 over root x times root x plus 1 squared. Box that, that's the answer. So what was the problem? To simplify? Okay. Well, 2 out of 4 better than 0 out of 4, right? Okay, don't answer me. 37. Find the equation of the line perpendicular to the tangent. Isn't that the normal? Why don't they just say normal line? At the point 2. You can't get a problem easier than this, people. We did this on the last test. Well, how do you find the slope of the tangent line? Derivative. Take the derivative. Okay, this one's just too easy. 3x squared minus 3. Now what happens when I plug 2 into the derivative? What do you get for the slope? 9. Now that's the slope of the tangent line. They want the normal line. So what's the slope going to be? The negative reciprocal of that. So y minus 3 equal negative 1/9 x minus 2. Box that. That's the answer. Just remember, when you write an equation of a line, you need a point and you need the slope. And how do you get the slope? From the derivative. That's what happened. Okay, that was a strange one. 39. I think we'll be saying this one on tomorrow's quiz. When I'm saying that, are you guys like circling it?
Yeah.
Okay, good. Well, it doesn't matter because if you come tomorrow morning, it's like a carbon copy of the quiz, man. Just to help you out. We're AB, man. Okay, here it says, write the equation. It says, find the points on the graph where the tangent line is parallel to the x-axis. So this is like the other problem we did. This is a cubic thing. So where is the tangent line parallel to the x-axis? Well, what's the slope of a line that's parallel to the x-axis? 0. So we want to know, when is the slope equal to 0? And what tells me the slope? The derivative. So what you do is you take the derivative and make it equal to 0. So this derivative is just nonsense. 6x squared minus 6x minus 12. That's just nonsense. When is that equal to 0? Well, you need to solve that equation. Well, I would factor out a 6. But that's just me. Some of you like the big numbers, eh? You like the big numbers, eh? X and x, 2 and 1 minus plus. So x equals either 2 or negative 1. So this is negative 1 comma something. That point there is 2 comma something. Now they want the coordinates of the point. So that means you got to get the y coordinate now. So how do I get the y coordinates? You plug it back into the original. You guys are going to do that. I can do one of them for you. Which one do I want to? I'll do negative 1 then. If I plug in negative 1, you get negative 2 minus 3 plus 12 plus 20. 32 minus 5 is 27. There. Bam! You can do the other one. Okay, 39. Okay, now we're kind of making headway. Not really. 40. What is the meaning of this? QQ4, but that's 58.
Yeah.
And that's 46. Thank you for putting it in order.
Wait, do we have?
Wait, no, 41.
We had 40. We just did 40. Oh, wait.
That's okay. My blood pressure medicine is working. 41. Hello?
Sorry. no meeting right now.
What? I'm videoing,
Oh,
just for you.
yeah. Sorry, it's tomorrow actually.
It's tomorrow?
Yeah, I mixed up the dates.
Wait, then how come you weren't here then? Okay, I don't wanna know. 41. Where's 41? 4x all over x squared plus 1. Okay. If you draw this, you don't have to draw the graph. I'm just drawing it just for funsies. X and y. Well, it looks like this. And then what are we trying to find? It says, write the equation of the tangents at the origin and at the point 1, 2. So here's origin, and here's, I don't know where 1, 2 is, somewhere over there, I don't know. 1, 2. Write the equation of the tangent lines right there, whatever it is. Okay, well, we got the points. We just need the slope. What tells me the slope? So you gotta take the derivative now. What should I lift and separate? No, you cannot lift and separate. So you gotta use the quotient rule. Okay, who's got this? Mariama, read it off your paper.
X squared plus 1 times 4 minus 4x times 2x all over x squared plus 1
There
squared.
we go, there you go. Low d high minus high d low all over denominator squared we go. Now, do I need to simplify this? If you want to, you can. But why not just plug in the numbers right now? Because some of you could probably go make mistakes if you try and simplify that, yeah? Because you guys need your money back from algebra. So, what happens when you plug in 0? Plug in 0, go. 1 times 4 minus 0 times 0 all over 1 squared. What is that? 4 over 1. So the slope right there is 4. So what's the equation of that line? Y minus 0 equal 4 times x minus 0. I'm just putting, of course you would write y equal 4x, right? I'm just doing slope form so you guys can see. Now what about this one here? What's the slope of that tangent line? Well, you gotta plug in 1 into the derivative, right? Because the x coordinate is 1. Remember, it is not the slope until you plug in the number. So if I plug in 1, you get 2 times 4 minus 4 times 2 all over 2 squared. What is that?
0.
That's 0. Oh, so this is a horizontal baby. Like that. The slope is 0. So what's the equation of that line then?
2.
Yeah, y equal 2. So there's your two answers. Okay, that's 41. 46.
Wait, we don't have.
We don't have 46.
I don't think I assigned 46. What is the meaning of that travesty?
Oh, maybe 4b.
No,
Ah, come on. There is no 4b. What are you guys trying to pull?
QQ.
What?
QQ.
Yeah, but we're not even QQ. We gotta do the 50s now. 54. True or false? It's a 50-50 chance. The graph of f of x equal 1 over x, which of course looks like this. That's a base graph, people. It says has no horizontal tangent. So there's nowhere on this graph where the tangent line will be horizontal. Well, you can kind of look at it and kind of see already. What do you say, true or false, just from the graph? It's true, but let's mathematize it. Let's compute the derivative. What is the derivative of this? Kawahara?
1.
Yeah.
Oh, negative.
Okay, I'll give you a hint. Change it to x to the negative 1.
So negative x to be 0.
Yeah.
Oh, negative 2.
Okay, there you go. Which simplifies to negative 1 over x squared. Can that ever be 0?
No.
What can I plug in for x to get 0?
Nothing.
Nothing, so that's why there's never a place where you're going to get a horizontal tangent. 55! Oh, I get it, Mr. Park. Every problem got to take the derivative. Yeah, that's what we're studying. We're studying derivatives. So yes, if you don't know what to do, compute a derivative, you might get 1 or 2 points. 55, multiple choice. No! That's just like the one we did over there! No! That's okay, this is on tomorrow's test, so here's what it is. It says, compute y prime of 1. In other words, compute the derivative and then plug in 1. Well, I see a product here, so you have to use the product rule. Derivative of the first, leave the second one alone, then you leave the first one alone, derivative of the second, right? That's the product rule. And then just plug in 0. No, plug in 1. But look, they have a chart there. Do I have to do it?
Yeah.
Boo! Okay, u prime of 1. Okay, now I need to shoot over. U prime of, somebody help me out here. U prime of 1 is 3. V of 1 is negative 1. U of 1 is 2. And V prime of 1 is 1. Negative 3 plus 2 is negative 1. That's on tomorrow's quiz too. So either then, I'll give you a hint. You're either going to use the product rule or the quotient rule. Or maybe both, I don't know. I haven't really made it yet.
Wait, what's the part? How did you get y equals 2 before you
Because the slope is 0. So how do you write the equation of a line? Oh, isn't the equation of a horizontal line going to be y equals something? Or you can just do point slope form. Y minus 2 equals 0 times x minus 1. But then that's 0, so then you get y equals 2. So you can still do it that way too. 55. Oh, how come I feel so tired? 58. You guys are just wearing me down. Y of x is equal to x squared minus 1 times x squared plus 1. Which of the following gives the number of horizontal tangents of f? In other words, like if I were to draw this graph, how many times you're going to get a horizontal tangent line? In other words, how many times is the slope 0? So what you got to do is you got to take the derivative and make it equal to 0 and see how many answers there are. Well, how do I want to take the derivative of this? Should I use the product rule or should I multiply it out before I start? Yeah, because look, if you multiply it out, you can get difference of squares, x to the 4th minus 1. So what's the derivative of this? 4x cubed. So if I were to solve that equation, how many answers would there be for x? 1. Just 1. X equals 0. There's only one time where the slope will be 0. When x is 0. That's it. Okay, now we're on QQ. So what is the meaning of this travesty? You got QQ4 twice. Does that mean 8? QQ8? And QQ2? This is strange. No, number 2, no, we haven't seen a problem like this before. This is a good problem. A line normal to the graph of f at the point 1, 2. So let me ask you this, are you guys drawing a picture? No further questions, Your Honor. Passes through the point negative 1, 1, right there. Then which of the following gives the, okay, so this is the normal line. That's the normal line. What's the slope of this line right here? How do you compute slope? Y minus y over x minus x. What's the slope? 1/2. That's the normal line. So therefore, what would be the slope of the tangent line, which is perpendicular to that? -2. So the question is asking, what is f prime of 1? Now, this is where you got to understand the notation. F prime of 1 means what happens when you plug 1 into the derivative? Well, doesn't the derivative tell you the slope of the tangent line? And when x is 1, right here, do we know what the slope of the tangent line is? Yeah, look at the picture. It's -2. So the answer is -2. So again, you got to understand the notation. Number 4. F of x is equal to x to the 4th minus 4x squared. Find all the points where you have a, okay, so this problem is on the quiz tomorrow. So find all the points where there's a horizontal tangent. Now this is a 4th power equation. The graph could look something like that. So there could be 3 places where there's a horizontal tangent. But it doesn't matter. It doesn't matter. You don't even have to know that. Just take the derivative, which is 4x cubed minus 8x. That's easy. And then I want to know when is the slope equal to 0. Solve that equation. That's all you got to do. Okay, how do you solve this equation? What do you do? Factor out of 4x. What's left?
x squared minus 2.
x squared minus 2. So what are your three answers? X equals 0 or plus or minus root 2. So there are 3 times where so it's going to be here. Negative root 2 comma something, 0 comma something, and root 2 comma something. That's where the slope is going to be 0. And I will let you plug it back into the original to get the y coordinates. I'm not going to do that. You guys are going to do that. Okay, part B. Write the equation of the tangent line when x is 1. Well, when x is 1, how do I find the y coordinate? You plug it back into the original and you get, come on, that's easy. 1 minus 4, negative 3. Now, how do I compute the slope? You plug the x coordinate into the derivative, because the derivative tells you the slope. So what happens when you plug in 1 here? You get 4 minus 8, negative 4. So just point slope ukataise it. Y plus 3 equal negative 4 times x minus 1. That's how easy it is. The derivative tells you the slope of the tangent line. Part C. Oh yeah, write the equation. Normal line, come on. How do you write, if this is the tangent line, what's the only difference between the normal line? You take the negative reciprocal of that, that's 1/4, that finished. Okay, now do we have a better understanding of the derivative? It's the slope of the tangent line. That's all the derivative tells you. But you can do a lot of things with that. We're going to spend the whole semester learning derivatives. Okay, today we're going to learn physics. Okay, I hope the other class doesn't have this many questions. You know what, I'm just going to tell them, watch the video. Man, that was crazy. That's okay, that's why I'm getting paid big bucks. You know what, it's good to be sponsored by TI calculators. You know like how pro athletes, they get like endorsements? Like Peyton Manning, what does he do? Papa John's? Like I think they pay him like, what did they pay him just to do commercials for Papa John's? Probably like $5 million, yeah? 10. I don't get that much, but TI calculators, since I use a TI calculator, I get paid 1.2 million a year just for that. It's pretty good, huh? Or was it $12, I think? Okay, today we are learning, this is physics, okay? So I'm trying to think of the fastest way to teach you this, because look at the time, we only get like 20 minutes left. We're in trouble. Okay, here. So, position, what do you guys use for position? Okay, time, our book uses S for position, I don't know what you guys are going to do. So if this is the graph of position, what does the slope of the tangent line tell you? Because we learned this in the instantaneous velocity. Oh, and what tells you the slope of the tangent line? The derivative. So if you take the derivative of position, you will get velocity. Now, what if this was the graph of velocity? What does the slope of the tangent line tell you? The instantaneous acceleration. Oh, so if you take the derivative of velocity, that's how you get acceleration. Because the derivative simply tells you the slope. And we learned from physics, the slope is the instantaneous velocity or the instantaneous acceleration. So there you go. That's kind of like today's lesson right there. If you take the derivative of position, you get velocity. If you take the derivative of velocity, you get acceleration. So, I'm just going to do one problem for you. Okay, that will answer all the questions. Okay, don't look. Don't look! I'm going to make a problem that comes out nice this way. This is how I write quizzes and tests. Position is equal to t cubed minus 6t squared plus 9t minus, give me a single digit number. 2, okay, 2. Okay, this is your position equation. So there's so many questions, okay, you're going to get 6 free response questions on the AP exam. This is going to be one of them. A particle moving on a number line. In fact, you know what? I'm going to call it x because it's moving on the x-axis. Sometimes on the AP exam they call it y because the particle is moving on the y-axis. But it really doesn't matter. Let's just say it's moving on the x-axis then. Okay? Let me ask you some questions. What is the initial position of the particle? What does that mean? Initial position. Huh? What does initial position mean? Where you are at the very beginning. And what is the very beginning? When t is 0. So, what is the position when t is 0? Well, what happens when I plug in 0 for t? You get -2. So that's called the initial position. So here's the x-axis. A particle starts at -2, and then it's going to start moving. Okay, so what kind of questions can you expect to see in tonight's homework? Well, they're going to ask you, when is the particle moving to the right? When is it moving to the left? When is the particle at rest? What does that mean, at rest? Yeah, it's not moving at all. In other words, the velocity is 0. When is the particle speeding up? When is the particle slowing down? These are all the questions they're going to ask you tonight. So, but you just do the problem the same way every single time. And nobody gets hurt. Okay, here we go. If this is the position equation, I need room here. Okay, there's the velocity. This is too long. Okay, if this is the position equation, how do you compute velocity? I just told you. You take the derivative, that's right. Except instead of x being an independent variable, now t is your independent variable, which is, of course, is time. What's the derivative of this? 3t squared. Just use the rules that we learned. Minus 12t plus 9 minus 0. The derivative of 2 is 0, right? There you go. That's the velocity equation. Now, in order to answer these first 3 equations right here, all you have to do is make a number line for that. Now we're going to start making number lines. So how do I make a number line for this? You factor out the 3. Okay, that's factorable. Can I make a number line for that? Yep, there you go. What goes on this number line? What makes that thing 0? 1 and 3. Think of a number bigger than 3. 4. Plug it in. Positive times positive times positive is positive. How do I know it's going to alternate like that? Because you got odd powers. Or if you think of the graph, it's a parabola opening upward, see? So above, below, above. Plus, minus, plus. Or if you don't know anything, just plug in a number, like plug in 2 and then plug in 0. You got to get that number line. So let's answer the question. When is the particle moving to the right? Now, if you're on the x-axis, moving to the right means you're moving in the positive direction. So what tells you when the particle is moving to the right? When the velocity is? Okay, now look at the number line. When is the velocity positive? No. Okay, this is time now, so there's no such thing as negative time. From 0 to 1, and then 3 to infinity and beyond. Wait, Mr. Park, how come it includes 0? It doesn't include 3 or 1, but it includes 0. How come? That's because at 0, isn't the velocity positive? So therefore it's moving to the right. So that's why you have to include 0. But how come at 1 it's not included? Because at 1, the velocity is 0. If the velocity is 0, that means it's not moving at all. So that's why it's not moving to the right there. You guys understand? Okay, when is the particle moving to the left? When the velocity is negative. Look at the number line. When is the velocity negative? Between 1 and 3. See how easy, just make a number line. When is the particle at rest? That means it's not moving. That means the velocity is 0. When is the velocity 0? 1 and 3. T equal 1 or t equal, just do this. T equal 1 and 3, good enough. Okay, now here's something now we got to remember our physics. How do you tell if the particle is speeding up or slowing down? No, not just acceleration. The velocity and the acceleration. If the velocity and acceleration have the same sign, it's speeding up. If the velocity and acceleration have opposite signs, slowing down. Does that sound familiar? If not, don't worry, I just told you. If the velocity and acceleration have the same sign, that means it's speeding up. Opposite signs, slowing down. Oh, so Mr. Park, that means I need to make a number line for the acceleration as well. That's right. So here's your velocity. Well, actually, all 3 of these are velocity. If I want to compute acceleration, which one of these 3 is the easiest to compute the derivative? Like if you pick this one, you gotta use the product rule. If you pick that one, you gotta throw the 3 on the side like an unwanted pet. Yeah. Or should I just do this one, turn by turn? Yeah, I think this one is the easiest. So what's the derivative? 6t minus 12 plus 0. And is that factorable? Yeah, that's why I made the problem, so it comes up 9. If I just threw up any numbers there, all hell would be breaking loose right now. There you go. Yeah, I can make a number line for that. Now, when you make your number lines, I would highly suggest you put one on top of the other. So, when is this equal to 0? At 2, plug in a number bigger than 2, at 3. Positive times positive is positive, and how do we know it's going to alternate? Yeah, odd power, or duh. If I graph this, it's a line, right? Below and then above. Whatever you want to do. Okay, so let's answer the question. When is the particle speeding up? When the velocity and the acceleration have the same sign. That's why if you stack them one on top of the other like this, where do they have the same sign? Between 1 and 2, right? Because look, negative, negative, right? And where else do they have the same sign? From 3 to infinity and beyond, right? Because look, positive, positive. That's why if you line up the number lines, it's easy to tell. When is the particle slowing down? When the velocity and acceleration have opposite signs. So where do they have opposite signs? From 0 to 1, because that's positive, but that's negative. And where else? Where do they have opposite signs? Between 2 and 3. Right? Because look, between 2 and 3, the velocity is negative, but that's positive. That's why you line them up, it's easy to tell. That's what you got to do tonight. So whenever they ask you, some of the problems tonight, they're going to ask you, describe the motion of the particle. That's what this is. The motion of the particle is when is it moving to the right? When is it moving to the left? When is it speeding up? When is it slowing down? So does everybody understand? To tell if a particle is speeding up or slowing down, you have to look at both of these, not just one of them. Now, of course, on the next quiz, I don't know if we're going to have another quiz. In fact, I'm sure this is a problem you got when you took physics. Okay, this is the graph of velocity versus time. Let's say the velocity graph looks something like this. Right here. Let's call that 3. Right there. When t is equal to 3, is the particle speeding up or slowing down? Well, how do you tell if a particle is speeding up or slowing down? You got to look at the velocity and acceleration. Well, if this is the graph of the velocity, what is that? Is it above the x-axis or below? It's above, so it's positive, right? Okay, now what about the acceleration? Acceleration is the derivative of velocity. And what does the derivative tell you? The slope. So right at this point, what can you say the slope is?
Negative.
It's negative. So they have opposite signs. It's slowing down, that's right. Now on the AP exam, they always ask you for a reason. So you're going to say the particle is slowing down, and why? Because the velocity and acceleration have opposite signs. And if you want to be more specific, you can say velocity is positive, acceleration is negative. That would be nice. You guys get it? All right, so now I think on 1 or 2 of tonight's homework problems, to make your number lines, you got to use your calculator because you're going to take a derivative and it's going to be unfactorable. So you got to use your calculator to make the number line. You guys know how to do that, right? This is pre-cal. Okay, let's say the acceleration. Let's say the acceleration is something ugly and unfactorable. So you graph it on your calculator. Let's say, let's do that. Okay? So, how would you make your number line for the acceleration? Where does it touch the x-axis? At A, B, and C. Except, of course, you're going to calculate the 0, right? Or the root. You guys know how to calculate where the graph crosses the x-axis, right?
Yeah.
And then, if it's above, it's plus. If it's below, it's minus. If it's above, it's plus. If it's below, it's minus. That's how you make your number line. So you just simply graph it on your calculator and you look where is it above or below the x-axis. That's how you get the signs on your number line. But I think you're only gonna do that on 1 or 2 problems. All the rest, no calculator. You're gonna do it like this. You factor it. It's gonna factor nicely and you make the number. All right, we finished kind of early, 8 minutes early. That's not bad. All right, let's stop the video. Uh-huh.
Where did the velocity equation come from?
The velocity equation comes from the derivative of the position. Yeah. So you take one derivative, you get position. You take another derivative, you get acceleration.
Did you write your paper Japanese?
Oh man, if I only knew this when I took physics last year, I would have dominated.
No, I don't let you use it.
No, but at least if you knew like slope, what to look for, right?
I have a 10 point.
You already have
I'll
to check
take
the 10 point.